As you might expect, we have a number of questions that have showed up in the question box. First one I have is for Scott Bergkamp, and the question is, are you suggesting that you can monitor aggregate moisture on the fly instead of entering a lab-derived value from a stockpile?
No, I'm not suggesting that. What happens there is when you have an aggregate moisture, you can simply enter it, and then the system takes care of any subsequent calculations.
This is for Jordan. Jordan, do you recommend a chip seal prior to a slurry or microsurface application?
I think that it's a good product to use when a road has a lot of cracks and whatnot already on it. We've actually done recently some towns. We've done a micro mill in some towns with roads that were in some pretty rough shape, and a micro mill meaning just scratching the top surface to try to smooth it out completely. If the road is in pretty bad shape, meaning lots of cracks and whatnot, then yes, we absolutely would, and that would extend the life even more than the 5 to 7 years that I already explained.
This is for Brian Darling. Is there any ideal time, temperature to conduct crack sealing?
Absolutely. We generally want to see the crack sealing done in the spring and the fall when the weather is cool. That way the asphalt is relaxed. Your cracks aren't opened all the way up, but they're not closed all the way up. We want that mid-movement to get the sealant down in those cracks, and then that allows movement both for the summer and the winter.
This is a question for Scott Metcalf. What type of crack seal material would you recommend before a slurry? And did you say to seal the cracks 3+ weeks before slurring?
Typically, I recommend a hot applied crack sealant. Crafco and multiple other manufacturers could direct you to the proper crack sealant for your environmental conditions. Historically, you'd want to make sure that that crack is sealed 2 to 3 weeks before. If you can get it done 6 months, as Brian said, in the fall or the spring, when that crack is at its optimum opportunity to get filled, fantastic. That'd be great.
Here's a question for Bobby. How durable is the bonding wearing course layer under the frequent freeze thaw conditions?
You will certainly see some cracking with it, and that's where having that crack seal ahead of time certainly helps to seal up that layer, as well as with the heavy tack layer. But like any thin overlay with a freeze thaw cycle, you will see some of that cracking. The difference is because of the heavy tack layer that's underneath and combined with the crack seal, is that the moisture won't penetrate all the way down and through.
Another question is the classical, how thin is thin? How thin of a surface is classified as a thin overlay? Is 1 to 2 inches still thin, or does that fall into a separate category? Let's start with Jason on that one, and maybe somebody else might have a comment to make too.
In our tech brief that we talked about that, and we basically make it as asphalt mix in place less than 1.5 inches. That is the max.
This is a question for Brian Hansen. How does hot in place recycling compare with cold in place recycling?
The processes are different. Like I said in my presentation, typically hot in place recycling is going to just address the distresses in that top couple inches of pavement. Cold in place typically addresses distresses in that 3 to 4 inch depth. So, hot in place recycling, you use heat to soften the pavement and manipulate it. Cold in place, they're typically using some sorts of additives, emulsion. Sometimes they use a fly ash or a lime or a cement to help stabilize that pavement. So different additives, and really they're looking at different depths of pavement distresses.
This is for John Roberts. When diamond grinding, how do you usually address adjacent asphalt shoulders to ensure lateral drainage?
That may require something that we call a feather pass, and it depends upon the break at the shoulder interface. If you have a mild break that is, like a 0.2 slope, 0.3 slope, chances are you can just feather through with the outside lane edge diamond grinding pass. If in fact you do have a situation where the asphalt shoulder has raised up a little bit or just is proud from the pavement surface and will trap water, many DOTs use what they call a feather pass, which is almost like a skim coat, if you will, of diamond grinding along that shoulder.
Here's a question for your question. Is there any alternative and acceptable pavement removal other than lift out method for full depth patching of CRCP? John Roberts, do you want to take a shot at that or not?
I certainly will, yeah. Yeah, there are a number of different methods. The pin and lift out method is certainly the cleanest method because that allows you to do your saw cuts on a separate operation, different night, drill your holes on a separate operation, different night, and then you come in and remove multiple slabs, put them on the back of a semi very quickly and run down the road. That's certainly the cleanest and most efficient way to go about it. But most certainly you can make multiple saw cuts on either side of the distress, one saw cut being full depth, and then a second saw cut going halfway down to expose the reinforcing steel. Then at that point, you'd use a jackhammer to break up the concrete to the appropriate level and then scoop it out with a backhoe. The downside of doing that, of course, is that now you have a base repair that you have to effect as well, because pulling out that rubble is going to disturb the base, and you're going to have to go back in with new material and compact it and so on.
Another question, this is for anybody who wants to answer, and I know that there aren't any agency folks on speakers list here, but I'll throw it out anyhow. With respect to friction, texture, and skid resistance, what are the typical requirements for the surface aggregates?
So I guess, Jim, I mean, that depend on if you're using a bonded Waring course or even a chip seal, doesn't in Slurry or micro. You want a good, hard, durable aggregate that doesn't have a polishing characteristic. You want good cubical crushed faces, so you get good aggregate interlock. So I think it's critical for all preservation treatments that you want a good, hard, durable stone. You don't want something that's polishing, or if you know it's a polisher, especially if it's going to be a surface treatment, you probably wouldn't want to use that aggregate.
And Judy, I'll let you take this last question when I get done here, but I want to thank all our presenters, and thanks to the conference session, especially the case studies and logo sponsors, and all of you who have waited through us for 2 hours plus. Feel free to register to attend any of the remaining sessions that'll be happening all week, and any of the regional partnership meetings that'll be held as well.
All right, I want to thank the 340 attendees who have hung in there for the extra 16 minutes that this went. I think it was a great session, very informative, and I want to especially thank all of these presenters, because doing these presentations in a 10-minute time window is very, very challenging. So this was our alternative to a field demo day, which we would typically have in a national meeting, face-to-face meeting. This was an opportunity to hear essentially about a buffet table of various preservation treatments. So thank you all. Have a great evening.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.